All right, welcome everybody to the weekly Dalton Community Hangout. Today we've got a very special guest, wicdev-wisryt. I believe that's the way it's pronounced. Depends on how you pronounce your Y's, right? Doesn't it?
Yeah, I always say wicdev-wisryt, but
Wisryt, yeah.
I answer to both.
Okay, very good. So to get things started, we're just gonna have a couple housekeeping items for Dalton. I don't think we actually have anything specific. But on the back burners, we've got this other issue of the trust metric, which we haven't made any progress on in the last 2 weeks or so. But just to remind everybody where we're at with that, we've got some functional we do have the functional specification for what the trust metric is. The idea where we're at right now is try to put that into Hoon to play with it to see if we can get something to work that we can prototype out, potentially for using in our own uses as measure of membership and as a sliding scale. So that's one thing we've got on the back burner. And then, of course, ever present, like what could we do in order to actually generate some either revenue or anything else like that. So those are the basic things we've got on the back burner sort of perpetually. Last update from last week is that we're incorporated now, so we do have a legal entity that backs all this up. So if we ever do need to have either some legal contracts or any of that other stuff, we're ready to go. And we got to keep the SIG in front of Dalton, so which is kind of great. So awesome. Well, so last week we had Rob Strickfer on and to talk about the public key infrastructure issue that's sort of bubbling up in the Urbit space. And this has all been sort of kicked off by very high gas prices in Ethereum. Now, it's probably the case that these gas prices will come down, and they have come down even since last week. It's also likely that they will go up again, and that there should be some choppiness in this market until it's either ultimately sorted out with ETH 2.0 or either some other thing. But it's really very much worth having the conversation now about what does a PKI, public key infrastructure, mean for Urbit, what it might look like if we were to do something internally or something that's not Ethereum. And so I invited wicdev here to talk about some of his thoughts. He's put some really good thoughts down on paper, so to speak, on the Urbit Dev Google group. So if anybody is interested to read through some of this conversation in written form, that's definitely the place to go to see what's happening there. But so wicdev, I know you've put some thought into this. You have some of your own perspectives. So could you give us kind of like start from the basics, kind of why we're on Ethereum in the first place, what its kind of advantages are, what its disadvantages are, and some of the ways you see that moving forward, and then maybe even hopefully getting into some of the technicals about what that means.
Yeah. I mean, so the like one thing to keep in mind is the worst case scenario, of course, is that we all just use comments, which still actually does preserve many of the benefits of Urbit, but is really not something that, like, that's not a world we want to live in if at all possible, because a lot of the reason why people use centralized services is because their identity is there, because they want to have a permanent identity, and comments are and by their nature have to be impermanent. But it's always good to have in the back of the mind that, like, it's not the end of the world if we don't solve this, or if it becomes a situation where not everyone ends up with the planet. But still, I think it's really important to try and get this right. And so the as I laid out in that blog post about address space, I don't know, 6 months ago or something, there's a few different ways that you can do identity systems. The most common ones out there right now are centralized, which scales well, but is centralized with all the problems associated with that. The only way to do them decentralized that we've been able to find is, while still being permanent and having the other properties that we care about, particularly just permanence, is with blockchain. And what you need from the blockchain more than anything is just an ordering on your transactions, so that if I say I transferred this entity, this ship to you, then I can't go and try and transfer it to someone else. because we can prove which one happened first, and that's the one that's real. And that's the double spend problem. That's what blockchain solves for you. And so that's why we need a blockchain in order to have these permanent identities. And then the question is, what, with blockchain and what are the trade-offs involved in all of that? The main reasons we chose Ethereum originally is, number one, you need it to be a sort of serious blockchain that is also large, because you need it to not be something that can be easily 51% attacked. Because if you, as an application, end up being worth, for example, significantly more, or a significant fraction of the value in that blockchain, then it becomes profitable to do a 51% attack potentially for a really long time. If we were on a blockchain that's worth $1 million total, and we have $100 million of value on there, then a 1% attack makes a lot of sense, because you're not really giving up that much in terms of miner fees compared to what you could get from an attack on Urbit. So it needs to be a big one, and it needs to be, when I say serious, I mean basically they have to have a plan for stuff like scaling, that's like where they're actually looking at the real problems. Many of the Ethereum killer chains are just cheaper because fewer people use them, and if the same number of people use them, then they wouldn't be any cheaper, which is not something that is useful for us. The other thing we need is we need it to be actually decentralized, which rules out a lot of sort of federated chains, a lot of chains that assume that there'll only be a very small number of full nodes, and sometimes even a fixed set of them. In my opinion, this rules out things like Stellar. This rules out BSV. There's some discussion about, but it certainly rules out Bitcoin Cash, in my opinion. And there's you could argue about any of these individually, but in general, those are the reasons why I would avoid those. And you end up basically coming down to, at the time, 2, and now more like 3 basic options. One is Bitcoin, a second is Ethereum, and then a third is to basically build your own blockchain in some way. Cosmos is a good framework for this. Cosmos wasn't as mature at that time as it is now, and so if we just look at Bitcoin versus Ethereum, then the decision is largely comes down to basically Ethereum, they're relatively similar in size. I mean, Bitcoin is obviously larger and has more hash power, but they're both at the top of their respective algorithms in terms of it's relatively hard to take an ASIC built for Bitcoin and use that on Ethereum, and vice versa. But the biggest advantage of Ethereum are that you can write a fairly small amount of code that you can then vet very thoroughly and have something that works pretty quickly and pretty cheaply, because smart contracts are built into it, because data availability is built into it, because all these things are already built into it. And you can use a lot of off-the-shelf tooling around what's around. I mean, things like Etherscan, inspecting contracts, all these sorts of things. You can use off-the-shelf tooling, and it means that you can get where you need to go a lot faster. Also, just the developer community around Ethereum is bigger and more active, and generally has done, in my opinion, a better job of building tools around it that are useful for us. the reasons why it might have been like why it might be better to like why you might prefer Bitcoin would be because it is larger, because it has a better story around scaling. Ethereum recognizes the problems around scaling and has come up with a long string of potential solutions to it in specific cases. But Bitcoin is like right now in a better place as far as scaling goes, at least for its core functionality, and that's partially because its core functionality is much smaller than Ethereum's. But anyways, yeah. So that's essentially why we chose to use Ethereum at the time, and the main thing that's changed since then is that something like Cosmos is an option, where you can, writing relatively little code, spin up a blockchain with whatever parameters that you want. In particular, so a common way to do that is to use the Tindermint algorithm, which is usually a proof of stake style algorithm, but you can also use it where you have a fixed set of miners, basically. And the most natural way to apply that to Urbit would be to say, we'll keep track of the galaxies on like Ethereum or something, but then everything else we'll keep track of by saying that the galaxies are the entities that vote on which transactions to include, and they come to an agreement amongst themselves using the Tendermint algorithm or hot stuff or something similar. And this is robust as long as the galaxies are generally in agreement with each other. And you need at least, with the standard parameters, you need at least 33% of the galaxies to be trying to censor you or to try to or just being uncooperative to cause problems. And so then the main advantage of Cosmos is that because it's essentially our own blockchain, it has only our own data on it, and that's basically the only way to scale blockchains is to not mix all the data from all apps together.
How does finalization work with Cosmos? Do you know?
Say again?
How does finalization work with Cosmos?
I need to learn more specifically how it works, but in general, everyone signs each other. Like, so someone proposes a block, and then you have up to 2/3 of them. It's usually then yeah, you go around trying to get signatures from 2/3 of the other galaxies, and once you have a block that's been signed by 2/3 of the galaxies, then it's considered essentially. I think then it's considered finalized, and as long as someone's not signing, 2 different forks or something, then this will work fine. And in particular, it's resilient to up to 1/3 of people signing 2 different forks, if that makes sense.
Yeah, yeah.
Right. So, yeah, to conclude my opening statement is basically that those are the 3 basic options for how we could go forward. With Cosmos, I can imagine exactly how it would look. With staying on Ethereum, there's a few different options. Basically as many options as there are Ethereum scaling proposals, which there's a lot of. Rollups seem the most straightforward to me, but they have their issues. You could do a rollup style solution on Bitcoin as well, although it would probably not be technically a rollup. But once you're doing something like rollups, then you're using a lot fewer of the features of Ethereum, and you almost may as well switch to something like Bitcoin. So those are the ideas that we're looking at primarily for longer term solutions to this, although I'm still open to other options. Definitely, I'm still very much in research mode. A short-term solution is potentially to treat unspawned planets on the Urbit network almost as though they were moons. So you would be able to go to your star and say, okay, I'm going to spawn this planet, and it'll give me a key, just like as if I were creating a moon, and then I could give that to someone, and then they could boot with that planet. And when someone wants to talk to that planet, they check Ethereum and they're like, oh, there's no planet here. And so I'm going to ask their star about it, and then you get the keys from the star. This has the advantage that obviously it doesn't require anything. It doesn't require a transaction on the blockchain to give someone a planet. But it has the disadvantage that you're beholden to your star in the same way that moons are beholden to their planet. You can't escape your star. If you're this sort of a moon, you can't, like in order to breach, you have to tell your star about it, and your star has to cooperate. And your star could always just breach you on its own and take back that planet. To the point where I would actually call them, someone suggested planetoids, as like they're not sovereign at that point. But it could be a useful onboarding tool for people who want to try it out. Give them a planet, a planetoid, and give them some kind of. Ideally, you'd have some kind of like you should be able to take that ticket and present it to the Azimuth contracts on chain, and the Azimuth contracts would give you that planet, so that you could easily kind of upgrade it to an actually sovereign planet. But
it's like a side message, and then you can do EC recover on chain.
Exactly. That should be a very small change to the Azimuth contracts. If you don't want to change the Azimuth contracts at all, then you can't do that, obviously. But yeah, that should be very easy to add, and I think would be well worth it.
There's like a small issue with like double spend there or something, right?
Well, there's an issue with double spend in the sense that as long as you're still a planetoid, your star can always take it back. They can breach you. They can take back your identity. They could issue that same signature to someone else. There are some mitigations for that. One is being able to present the signature on chain mitigates it to some extent. Obviously, they still can do this. Another is that obviously the star owner can just spawn this on chain after giving it to you off chain, and in order to, but like, how to put this. Since you're presumably running on Urbit and watching Azimuth and talking to other people on Urbit, we can probably detect pretty quickly when something like that has happened, and then we can have it yell at you and say, hey, your planet is not real anymore. Or else maybe you're the one who did this and you need to put in the new keys or something, but like we can yell at you, and then you can know whether you need to write a strongly worded review about that star owner. But yeah, there's like there isn't any technical way to, like, it doesn't prevent double spending in that sense. And so when you give someone a planetoid, you probably shouldn't be charging them. But then there's a whole nother, I don't know, from a market perspective, that becomes hard, because then if you want them to be able to turn their planetoid into a planet by just submitting it to the blockchain, then how can you charge them for it? unless that becomes a part of the azimuth contracts themselves or something. So it's, yeah.
So when it comes to rolling your own chain, so you mentioned this one potential option of Cosmos using their SDK to, and the Tindermint consensus protocol specifically, which has gone through much more battle testing than many other prototype consensus protocols, i.e., like even proof of stake in Ethereum. But there are other sort of options, and maybe you could, to the best of your knowledge anyway, walk through some of the kind of pros and cons with that. So you might have things like, why don't you just, like Ethereum's open source, right? There are side chains existing right now, like XDAI, who have just taken the underlying protocol and maybe changed some few features, where gas is being charged in a stable coin, and there are bridges between the two. So that's like one style solution, or just forking Ethereum for that matter. Another one would be something very similar to Cosmos, which is Polkadot. That protocol, which is using, I think, eWASM for their sort of core of whatever the blockchain that you spin up is, and then sort of this Cosmos SDK. So what are the differences between those kind of options?
I was just going to say they also support EVM. Edgeware, I just talked to the founder last week for another project. He, it's Edgeware, so they're like what going to be like one position to be like the first sort of parachain, and they're also going to support the EVM. Not just WASM.
Oh, okay, yeah, but that's important to know.
Where is a part of Cosmos or Polkadot, or something?
Yeah, it's a Polkadot parachain. It's positioned to be like one of the first sort of smart contract enabled parachains.
Okay, so
now.
Okay.
Yeah.
So my concern with the approach that XDAI takes, at least the way that I understand it, and I haven't looked into it very closely, but is that it's not clear what to do if the aggregators disagree. With XDAI, I don't know how they handle that. Is it a small set of with XDAI? What is the consensus algorithm?
Proof of authority at the moment, but they're moving to something like proof of stake. But essentially, what I'm getting at with that is, if you fork Ethereum, validation is on you, right? You got to figure that out. Right. If you straight up fork it, then you're stuck with proof of work, which is ASIC mining and all that other stuff. If you do something else, then you're in some either just proof of authority or proof of stake, as far as I can tell, right?
Right. I mean, if you fork Ethereum, it's easy to, like there's like command line flags to all those that can have you set it to proof of authority, for example. The issue with proof of authority in its most naive sense is that then it is completely centralized. You don't have a question of you don't have any recourse if someone's not taking your transactions, for example, in case of censorship or much of anything else. The other and so then if you want to switch to something like proof of stake, then you need basically you need an actual consensus protocol there, and Ethereum, like a straight up fork of Ethereum, doesn't have that. An answer to that is something like Tendermint. With the idea of using galaxies as your aggregators, is sort of a cross between proof of authority and proof of stake. From a technical perspective, it looks a lot more like proof of stake, except that there's a fixed set of aggregators. But the reason why it's more like proof of stake, first of all, is that they actually have a stake in it, but also that they can disagree amongst themselves up to certain limits. And so if you need that, then that's going to be, in a lot of ways, the actually interesting part. And so I would avoid just a straight fork of Ethereum for that reason. But I don't know. I'd have to look into it more to be to be completely sure that's correct. As far as Polkadot, I've heard good things about it. It does seem like it, from a high level, sort of the right solution. I think there's several people that are working on effectively the right solution. The sort of incidental characteristics of it, the fact that it supports EVM is nice because we could use our existing contracts. At some point, I would love to use Nock as our state machine and write it all in Nock/Hoon, but that's not terribly important. I don't like an issue with Polkadot is I don't think that it's like properly live yet, if I'm remembering right.
The parachains are some of the parachains are. I just spoke with the Edgeware guy. So like what he's told me was like EVM very soon, and then like WASM contracts relatively soon. And so like the parachains are live. They're basically doing testing on the main relay chain, which does not support contracts. I think it's just like aggregates block headers or something like that. And so that is moving forward. I feel like maybe by the end of the year, the relay chain will be ready, and then like something like Edgeware can, like, which is live right now, but is meant to be a parachain, can actually become a parachain.
Right.
Yeah, in a system like Polkadot, your validating set, or I should say your ultimate validation set, is still going to be whoever's guaranteeing the backbone, right? Like you're not going to be in control of your validation in a Polkadot world.
You're not going to be in control of your validation.
You're not securing your own chain with your own stake. You can get. That's the trade-off between Cosmos, the fundamental trade-off between Cosmos and Polkadot.
I think you can, because for example, Kusama is proof of work. So
yeah, maybe that's a generalization, and it's probably the same thing in Cosmos as well. Like you can get some pooled security with some other staking token, sure, if you want to architect it, but roughly that's how I understand it.
That's interesting. I'll have to look more into Polkadot because that seems preferable, probably, than the role of the child chain is primarily. Well, but so the role of the child chain would be primarily to just gather up the data, and then how does it guarantee that that data is going to be available? Do the people that are submitting to the main chain have to put up a stake saying that the data is going to continue to be available or something like that?
I don't have a specific answer to that, but I would assume that it's a bit of a hybrid in that sense, meaning liveness is not guaranteed in any given subchain. Just if you have data, you can verify that it is correct.
Yeah, I think they have like archive nodes basically, if I recall correctly.
But these archive nodes, are they cross-chain archive nodes, or you just have one for each chain?
I think you'd have one for each chain, most likely. I'm not sure.
Okay, I'll have to look into that. It's definitely the like the biggest thing in the last couple of years in terms of scaling. The biggest problem that people run into is data availability, and lots of solutions just ignore that. Although I don't think that Polkadot or Cosmos would do that. Something like Plasma is, as convoluted and problematic as it is because it is actually trying to solve that problem. Whereas a lot of the earlier solutions just ignored it. And I mean, and that's of course the merit of rollups is that they just put the data on the chain, but they don't make it available to any other contracts. They don't well, yeah, they don't do anything with it other than just put it in the call data, which solves the problem. Well, like, it solves the problem of data availability, but now all the data from all the different apps are on the same chain, which means you're limited in terms of how much you could scale. I think that rollups could scale us by 100x, maybe 500x, but not nearly to the degree that these other solutions could.
ZK or zero knowledge rollups, I think, can scale significantly more. Because like with like the right sort of proof, you could have like a so-called like succinct zero knowledge proof. I think that like it's like this the time it takes to like verify is I think like linear or maybe even like sublinear to the size of the proof. Or something like that. Or like you can like aggregate like proofs of many transactions together into one very small proof. And
I believe
so,
you can do that.
And so, like for example, like verifying with like Starkware only costs like 5 million gas. Like when you go to verify zero knowledge proof on the main Ethereum chain, which really like I mean that's kind of a lot, but like it's actually not that much, you know, if you think about it.
Right.
It's only like half an Ethereum block.
But I guess the question there is, like, where is the transaction data? Because if it's a standard rollup, then you're still putting the transaction data on chain, and that's still probably your ultimate limiting factor. And if you're not putting it on chain, then now you got to deal with all the data availability challenges.
Yeah. And that's kind of true with optimistic rollup too. I mean, to some extent, because like, I mean, what you're posting on the main chain is only block hashes. I mean, except in the case, you know, where there's like a fraud proof.
No, with optimistic rollups, my understanding is that you post the entire transaction on the main chain, but you don't execute it, you don't store it anywhere. It just goes in as call data, and so anyone watching the chain can just run those transactions themselves.
Okay, so maybe we should step back and kind of define some things here and like what these things are and why they're important. So optimistic, which is also known as optimistic rollups, and then ZK rollups. These are all been proposed more or less in the Ethereum context for scaling Ethereum. What are these things? What do they do? Why might we deploy them in some way? You want to go for that?
Sure, I can. Yeah, which there's a chance that I'll say something incorrect, but you know, so look up this stuff afterwards if you want to be sure. But my
research purposes only. Research purposes only.
Right. Don't trade based on this info. But definitely right. So my understanding of rollup in general is it's where you take all the transactions that you would have in a normal ETH1 contract, would have submitted those transactions, run them, updated these storage locations, emitted logs, and so on. And instead of doing that, you take the same transaction, which is usually defined in just a few bytes, you know, because it's 4 bytes for the function name, and then, you know, a couple arguments. It ends up being, you know, maybe 60 bytes or 68 bytes, and then a signature, which would be another 68 bytes, and so maybe 150 bytes or whatever. And you submit this as call data, like as a function, but then the function just doesn't do anything. It doesn't even emit logs. It's just there. And so the cost to do, you know, 100 bytes or something is, as of Istanbul, 16 gas per byte. And so it ends up being, you know, a few hundred gas for each transaction instead of 20,000 plus any of the storage locations you change, which, you know, for like spawning on our on our contracts changes like 10 storage locations, so it costs like 200,000 gas. And so this would take that and make it actually instead be only 100, a few hundred gas, which is something like a 100x improvement. Now you only get that 100x improvement because if you don't do one transaction at a time, because each transaction costs 20,000 base gas, and so if it's 20,000 plus a couple hundred is still basically 20,000. But if you roll up, if you put 1,000 transactions there, and each one costs 500 gas, then that's 500,000 and 20, so 520,000 gas. And so the average cost then is like 520, which is pretty close to just the cost of putting the data there. And then the second thing that makes it a true roll-up, so you could do what I'm calling, and because I haven't found anyone actually talk about them, but what I would call lazy roll-ups, which is you just do that, and everyone then reads these and runs them and comes up with their own opinion of what the chain is, and then if someone submits invalid transactions, they're invalid and you just ignore them. It's like considering that all transactions are valid, but just many are no ops. That would be one way of doing it, which has various advantages. But a true rollup also includes a hash of the state at the end of these transactions. And this makes a lot of things easier because you can then keep a proof around into that state of like who owns what, for example. And so you don't have to go back and look at all these old blocks. You just have to have proofs at whatever that state hash is now. And then the question is, how do you guarantee that hash is actually correct? There's two, the two most commonly proposed ways to do that are optimistic rollups and ZK rollups, zero knowledge rollups. Zero knowledge rollups use zero knowledge proofs to prove that hash is correct. Essentially, it's a little more complex than that, but it's essentially that. And the cost of verifying a zero knowledge proof is relatively cheap. It's on the order of hundreds of thousands, maybe a million gas. But if you roll up enough transactions, then it still works out to be fairly cheap. But the nice thing is that it can be proven on chain, and so if a transaction is accepted on chain, then you know that it followed all the rules, and so you can always trust your state hash. An optimistic rollup does not include a zero knowledge proof. Instead, you play a non-interactive verification game where basically if you believe that one of the transactions is illegal, or that the result is not that is not that hash in the end, then you challenge one of those transactions, and each of those transactions can then be actually run on the chain. So you have the contracts not only off chain, but you have the contract code on chain that you can run for any of those individual transactions. And if you win the challenge, then you should get a stake from whoever submitted that transaction, like that roll up. And so the advantages of the two different ways of doing it are that with ZK rollups, you have instant finalization. It's immediately, that it's correct. And you don't have to put up any kind of stake. The advantage of optimistic rollups is that you don't have to come up with a formulation of it that you can build a ZK proof about, which is relatively hard to do. So that's one advantage, is that you can just use the full power of the EVM. A second advantage is that even if you have a way to generate these proofs, they're relatively expensive to generate. Now that's only the aggregator has to generate them, but and I haven't looked at recent data on this, but it's quite computationally intensive to generate these proofs, while it's relatively cheap to to verify them. But again, the disadvantage of optimistic rollups are the opposite of ZK rollups, which is that you don't have instant finalization. Just because something's on the chain doesn't mean it's correct. And you have to have stakes and this verification game, which are easy to get wrong. And I mean, it's easy to mess up stuff like that.
Right. And then the reason why that's even an option in the first place is because if we were to run a scheme such as that, either optimistic or ZK, we don't need to actually migrate anything, right? We can mitigate cost by playing some of these games by playing these games where you're not changing state on Ethereum itself. You're issuing the data in call data, which can then be run, which, another protocol would have to kind of live on top of this, but that's essentially the main benefit, right? Is that it stays where it is. We don't have to move it.
There's some benefit to that. I actually think that the main benefit to a rollup type solution is that we maintain our current level of decentralization. Whereas if you switch to a system where the galaxies are validators, then you reduce your level of decentralization significantly. And it's not clear, whether that's some people are like, well, it's fine to have the galaxies vote on things, because what are the odds that 33% of the galaxies are going to, behave poorly, or at least what they would consider poorly. But the way that the galaxies and stars are right now, in general, you only have to get one galaxy or one star to support you, and then you can be on the network and do everything normally. They just need to send you updates. They need to route packets for you, and nobody else needs to agree to service you. But if you require at least 33% of galaxies to actively, to agree basically that you should be able to send transactions, that's another, that's a little bit less decentralized. Maybe it's acceptable, especially since the worst case is that if the galaxies all hate you, then you just use comments or something. But it's, well, I mean, not all, but if a significant portion of them hate you, then they can use comments. Also, I think to actually censor you, for example, they would need. It's not 33%. Yeah, no, that's right. It is 30%. It is 33% to censor you, because they need a 2/3 vote to make the block happen. And so if people aren't going to respect any block that has you in it, or aren't going to vote for any block that has you in it, then that block won't pass.
Right, and we should be specific when we mean censorship. We mean censorship over essentially who owns what, not necessarily what happens in the network.
Yes. Yeah. What happens on the network? I mean, as a comment or whatever, you're completely immune to this form of censorship. I mean specifically censoring transactions, which would be the case if I can imagine if we knew that some star was owned by some evil person, and someone was like, you know what, they shouldn't be able to spawn any planets, and so I'm not going to participate in anything that lets them spawn, or I'm not going to participate in the act of them spawning planets, which is very sort of believable. I could see that happening. But if you put it on something like Ethereum, then it's not like the way that it is now. For example, you're not participating in them spawning planets. You're just observing that it happened, which for many people is an important distinction.
Is there any?
Sorry.
I just was curious. Is there any meaningful difference between these rollups where there's something like proof of authority between the galaxies and the solution that you described with Cosmos, where it's basically still proof of authority. It's just that the individual transactions are cataloged individually rather than rolled up.
Right. So with a solution like Cosmos, it is proof of authority based on the galaxies. With or that hybrid kind of between proof of authority and proof of stake. With rollups, it is not. With rollups, anyone could submit a transaction, like a rollup transaction that has as many transactions under it, like inside it, that they want.
Okay.
And if they aggregate a lot of them, then it will still be relatively cheap. Even if they don't aggregate anyone, it's a small, like it's you can still do it if you really need to.
Let me reframe my question then. I think what I'm saying, or what I'm trying to say, is functionally it comes down to the same group of people or entities agreeing on those transactions for them to be posted. Is that right? Like with the roll up, if the galaxies have to agree to the structure of the rolled up transactions, or did I misunderstand that?
They don't have to agree to that.
Okay,
because
okay.
once it's put on, then everyone just looks at what's on chain and trusts that directly.
Okay, never mind. Thank you.
And then these aren't mutually exclusive, meaning if you wanted to pay the gas for a stateful transaction, you can do that, or you could submit a rollup.
Right. So I hope that can be the case. What I would love would be if we could have sort of a spectrum where we can say you can choose kind of where you want your planet or something to exist. And it can be on the regular Ethereum 1 contracts. It could be in a rollup if you want it to be faster, but you're okay with giving up some interoperability with other Ethereum contracts and such. Or you could even potentially say, you know what, I'm fine with this existing only on Urbit side because maybe I own the star, or maybe I trust the star, and or I want to let breaches go only on Urbit side, but ownership stays on my side, or there's all kinds of ways that you could do. Like there's all kinds of different combinations that could be useful depending on what people are trying to do. It's a little bit non-trivial to build bridges between these in a way where you can say, from within the ETH1 contracts, do you know whether what you're doing there is actually real? But I think that at least some of these it would be possible to just jump between them.
I mean, one small thing worth noting is people have also, like, I think Serum with Solana or something or another is using rollups to verify, basically do cross-chain protocol, where like instead of like having a rollup of a side chain, you do a rollup of like another completely independent chain, and then you can like use that to like verify things like on that blockchain and like be able to like port them across.
Yeah, I have seen that people are doing that kind of thing, which is encouraging, because we may be able to do that sort of a solution between our various options.
I mean, one thing worth mentioning is so in terms of ZK rollup, so Starkware has this. It's called Cairo. So it's a programming language to generate ZK zero knowledge proofs, or zero knowledge proof programs. And so like the world of writing ZK for zero knowledge proofs is becoming like a lot more sort of achievable. I mean, it's still kind of like a rudimentary sort of like assembly type of language, but like, I mean, that's quite a lot.
Yeah, it depends on what you're trying to prove. Like if you're just trying to prove like something is in a list or something, it's probably going to be a little bit more straightforward than if you have conditional logic. Yeah.
Sure. But I mean, there is like a DEX, Diversify, that's already been built with this. And like those are, I don't know if it's an automated market maker, but it's something or another. but that's like reasonably complicated, you know, and so that's sort of like reassuring to some extent. Or
yeah. The thing about Azimuth is that in a lot of ways we fit very well into most scaling solutions because we have properties like everything is owned by one person, compared to many apps have sort of shared pieces of data that are owned by different people. And so even things like Plasma, like which turns out to be not useful for very many projects, is actually reasonable for us, although I'm still wary of it. And in particular, I think things like zero knowledge proofs are going to be much easier to write for Azimuth than they would be for many other things. Certainly compared to something like Augur or whatever. Even I imagine that a DEX would be harder to write a zero knowledge proof for than Azimuth. I have been learning more about, like, I've been trying to buckle down and learn more about zero knowledge proofs and how to use them practically. Cairo is interesting. I hadn't seen that. I will definitely look into that. I would much prefer zero knowledge rollups over optimistic rollups if we can, because of the instant finalization and not having to play verification games. But it mostly just depends on whether we can write the contracts in a zero knowledge friendly way, and maybe Cairo is a solution for that.
Yeah, I'm wondering, because it was brought to my attention today because I was just like speaking to the Starkware guys for like a client that I have, I'm wondering if it comes
a couple weeks ago, last week. Yeah.
Say what?
I see they announced it just like last week, I think.
Oh, okay. But I'm wondering if it comes from, there's Eli Ben-Sasson, Starkware founder, zero knowledge guy, had a paper and like sort of implementation of this tiny RAM VM, which was like basically like a zero knowledge virtual machine with like its own like assembly language. And like, I mean, back then, like this was like, 3 years ago. I mean, it wasn't very fast at all, but I mean, I expect it made a lot of improvements. So I'm curious if the Cairo kind of comes from that. Yeah. They're also going to have shared state soon on Starkware. And so then, like, it could integrate with other applications. You could, maybe have like a star be owned by like a multi-sig or a DAO or something.
Mm-hmm.
But that's also like, a benefit that you get if you use like, say, like the optimism implementation of optimistic rollup is that basically it has like the EVM inside of the EVM to like verify the fraud proofs.
Right.
And so, everything sort of kind of works like right out of the box. I mean, it doesn't currently, there's still some issues, but like that's like the idea, and it is working with synthetics.
Mm-hmm.
I definitely admit that like doing like a roll up with knock where maybe like, you have like, you do the fraud proofs with knock, and so you write like knock in the EVM, and then you'd like have like sort of like governance to like register jets or something like that would be really cool.
Yes. Yeah, jetting knock with the EVM. That's the stuff.
That's the good stuff. All right, guys. So we are running a little long here, but let me just kind of wrap up the last question being like, all right, so we've got this conversation started. We have some maybe pros and cons. We're having like conversations about this. Great. But how does anything actually change? Like, how would this actually get either moved forward, implemented, all of that stuff?
Right. So there's a couple parts to that. Ultimately, anything that changes the Azimuth contracts themselves obviously has to be voted on by the galaxies. However, if our answer is we leave those behind entirely, for example, then there isn't a sort of formal solution to that. There isn't a technical solution to that. In general, it's not clear exactly what like which different solutions require, what level of buy-in. For example, if you just did the like unspawned planets, the like planetoid solution, unspawned planets are treated as moons. Technically, you don't even need to change the azimuth contracts. Maybe, we just put that on Zod and everyone, just respects it for now. But it's certainly something that we wouldn't do without plenty of discussion, and so that's why we're trying to get discussion going now. Is the like Urbit is bigger than Tlon, certainly, and I mean I guess I'm not really in a position to commit what we will or will not do in what circumstances, but in general, this is the kind of thing that the galaxies are there for, is to have a formal, even if not technical, way to decide these sorts of things. Obviously, ultimately, users can always do their own thing. You can always have a user-activated fork, which is what in the old days we just called a fork before cryptocurrencies. They can always fork Urbit, but the galaxies are sort of well positioned to ratify this sort of decision. Now, the galaxies are not necessarily the best people to come up with proposals for this, or to implement it. But their role as ratifiers, is important.
Yeah, and so maybe also just sort of paraphrase what you said there. Ultimately, the galaxies vote on the fate of Azimuth. They're not always the most technical minded, so they're not necessarily going to be the ones proposing anything. So conversations like this that are somewhat technical but should be available to a general audience should be encouraged. Content should be created around this topic so that when something does become more concrete, an actual like line of code that can be evaluated, then those folks can make educated decisions based on the work that we're doing right now. In other groups, like I could see like the provider standards group weighing in on this, all the other groups that we have in Urbit who are interested in this weighing in to help educate galaxies on how to move forward. And even if to move forward, maybe galaxies should just not do anything. And whatever solutions are sort of like soft forks or user-generated things that don't change things at a fundamental level, but change the way things work or something like that, right?
Potentially, yeah. Yeah, I definitely think conversations like this are good, and anyone who has ideas around this, send them to Urbit Dev or discuss them in on Urbit, or even just send them to me. You can DM me or something. Like these are all, I mean, they're certainly no decisions have been made, and we're still coming up with proposals. Yeah.
Cool. All right. Any other questions from the other two ships?
I mean, I have like a azimuth scaling question.
Sure.
So, I think my Urbit's like filled to the brim. Like I've used like the Urbit worker to deduplicate, and I mean, I don't know, maybe this is like another point of scaling that is, now that like there's so many communities and so many people are online, like.
Do you know what's using all the memory? In particular, the two that I've seen most commonly recently are chat store itself, which we do have a solution to, or air, which is really strange to me. And I've seen that a couple times recently, where it's using over a gigabyte, so 70% of the memory usage or whatever is in air, just basically just things that it's trying to send to my web browser, but my web browser is not on, or something like that, which is supposed to time out after 12 hours. But I suspect there might be something wrong with that right now. because it's filled up a couple times for me.
I could find out. It would be like a bar mass, right?
Bar mass, yeah. And then look under, is so vein E, for example, if that is a gigabyte, then that means most of it's in air. If it's in vein G, that would be in Gall. And you can look at which app it's in. It's probably then in Chat Store. There's a command you can run to deduplicate that. But yeah.
I mean, like the Urbit worker makes it work for like a few minutes now.
With Urbit worker, are you running compact or unique?
Unique, which is now meld, but I couldn't get the latest binary working. My operating system would kill it. Although maybe that's because I didn't have the event log.
Mine, I know I had to add a whole bunch more swap space because it was using like 8 gigabytes of RAM to deduplicate. Because when I was at 1.9 gigs of actual usage, then the hashcons arena was like 5 gigs, and so I had to add a swap space.
I thought about that. I was running free, but it didn't actually go up that much.
Okay, if free never got didn't actually get close to the edge, then that's probably not the issue. For me,
yeah.
I
know Joe just pushed yesterday, so maybe like latest commits fix it. Maybe
I'm actually using the old version that was in that first comment, which I probably shouldn't be using.
Yeah, is the 64-bit address space, is that like definitely going to not be until Jacques, or are you guys thinking about adding that into the C implementation?
It will not be for a little while. I could imagine it going into the C implementation. It wouldn't be that hard to do. But I mean, the issue here is almost certainly that something is exploding in size that shouldn't be. And one of the nice things about doing things with only 2 gigs of memory is that we catch those rather than letting them become huge. Because if you let those become huge, then running things like unique or meld now is impossible, right? If you have a 10 gigabyte loom, then putting that, hashconsing that into 30 gigabytes somewhere else, it becomes infeasible.
Yeah, so, I'm at like 1.9,
Right. Definitely look into whether that's air. And if it is air, in theory, within 12 hours, it should expire. If it doesn't, then like file a bug, and we need to figure that out.
Well, like the issue is that like maybe if I run it in offline mode.
That can be useful.
Because like, I mean, I kid you not, it's like I've got like 5 minutes.
Yeah.
Well, actually, no. The thing is, though, is I had it running for about a week after I deduplicated, like 1 or 2 weeks, but then it happened again. Like, I mean, it could have been air again, but I don't think in 2 weeks would air really fill up like that.
I think that when it fills up, so if it is clearing stuff every 12 hours, then when it fills up is actually something that happens like occasionally, but within a 12-hour period. And so it's the process is, it happens, there's a 3% chance of it happening every 12 hours. And so, it might look like it's fine for a few weeks, but it's not actually, the amount of time might not actually matter.
Okay, so I just need to like not touch it for 12 hours.
That's worth trying, and then see if that fixes it. When you bring it back up, you should be able to clear it. Yeah.
All right. A little Urbit help on the side.
Yeah, since I can't get into it,
Right.
Exactly. All right. Well, thanks, wicdev, for coming on, and the other two especially for continuing to show up every week. And yeah, we'll do this again. Probably, I'd like to make this a regular thing, like inviting people to have conversations here with us to get a better handle about what's going on in sort of the wider world.
I think it's great. I really like having these.
Cool. All right, everybody. Well, I'm going to turn off the recording now.
All right.
See you next week.